In the third part, we're gonna determine the x and y intercepts of a function. X-intercept means whenever this function cuts the x-axis, at this point will be the x-intercept. For the y-intercept, this is where the function cuts the y-axis. The point that represents the function where it cuts the y-axis is called y-intercept. So we in the previous part, we introduced this function notation, and we said that y is equal to f of x. To determine the x-intercept, we take f of x equal to 0. To determine the y-intercept, take x equal to 0 and replace it in the function. So to determine the x-intercept, take f of x equal to 0. To determine the y-intercept, take f of 0. Let's take an example and see how to calculate the x and y intercepts. F of x is equal to 2x minus 4 in this example. Let's calculate the x-intercept. Let's take f of x equal to 0. Replace it in the equation on the left side, and on the right side we have this function 2x minus 4. So 0 equal to the x minus 4. Let's find x, so we need to isolate the x, move minus 4 to the left side, and this negative sign will turn to positive. Now, to find x, divide both sides by 2 to get rid of the 2 over here. So 4 divided by 2 is 2, and 2 divided by 2, they will cancel and you will get x. X is equal to 2 for the y-intercept. So you write it in this way. X-intercept is x is equal to 2, and for the value of y, we already said that f of x is equal to 0 because f of x is equal to y. So if f of x is 0, this means that y is 0. And this is always the case for the x-intercept. Let's find y-intercept, the point that the function intersects with the y-axis. In this case, in the previous slide, we said that to find the y-intercept, take x equal to 0. So we will write f of 0 equal to 2 times x in this case is 0 minus 4. 2 times 0 is 0. 0 minus 4 is minus 4. So in this case, the y-intercept is 0, 4 because x is equal to 0, and the value we calculated for f of 0, which is the value of y, equal to minus 4. So this should be minus 4. Please correct it in your slides or take note of that. In example 11, g of x is equal to 3 minus the absolute value of x. The absolute value means if, let's remove this one. The absolute value means if you replace a negative number in x over here, it will change it to a positive number. For example, the absolute value of minus 2, let's use the other one, this one, the absolute value of minus 3, as you can see, this is a negative number. This will give you positive 3. For x-intercept, we said that y is equal to the function g of x. Take g of x or y, take g of x equal to 0. This means 3 minus absolute value of x equal to 0. Let's isolate x to find its value. So we're going to move it to the right side, and this negative sign will be positive. We want x. So we need to remove the absolute value to find the value of x. Whenever you have an absolute value, and if you remove it, the, the other side of the equation will be written as plus and minus the value you have on the other side. So add plus and minus, and you have 3. So the value of x is plus or minus 3. What does that mean? You have two ordered pairs. This means that this function cuts the x-axis into in 2 points. For y-intercept g of 0, we take to find the y-intercept, we take x equal to 0. Simply replace x here. Instead of x, put 0 and calculate 3 minus 0 is 3. So the y-intercept is 0, 3. And this is the point on the orthonormal system where this function intersects with the y-axis. Another example, h of x is equal to 2 minus radical x. Again, to calculate the x-intercept, we take this part over here equal to 0. So 2 minus radical x is equal to 0. Move x to the right side to find x. You will have 2 equal to radical x. To remove the radical, you have to square both sides. So you can find x. 2 to the power of 2 is 4, and radical x squared is x. So the value of x is 4. We can write now the point is 4, 0, or this is the x-intercept. For the y-intercept, again, we take x equal to 0. The same thing as we did in the previous slides. Y equal to h of 0, take x equal to 0, replace it in h of x here. You will get 2 minus radical 0. Radical 0 is 0, 2 minus 0 is 2. So the y-intercept is 0, 2. In part 4, we're gonna determine the domain and range of a function. In the first part here, we discussed the domain and the range of a relation, and we said that the domain are the x values, the domain of a function is the x values, and the range is the y values. Now, let's determine the domain and the range of a function. Given a relation defining y as a function of x, you have a relation. The domain is the set of x values in the function, and the range is the set of y values in the function. Similar to the relation, but we're gonna have one thing in addition to the things we studied for the relation. Let's see. Let's start with this graph. In example 13, determine the domain and the range of this function you see over here. This function is plotted, and we will start with the domain. We said the domain are the x values, all the x values that this function can take. So we look at the x-axis to find the domain, and we will start from the left to the right. in this direction. Okay, looking from the left at this function, we can see that this function is going like this in this direction. So we can see that this function takes all values of x. It takes all values of x. We say that this function starts from minus infinity and goes to infinity, which means that we write this in parentheses form, open parentheses, minus infinity. It, the x values starts from minus infinity from here and goes and ends to a plus infinity. Infinity is a very big number, very, very big number. That's why we say we're going back here, a very, very small number, minus infinity, to plus infinity, which means here we have a very, very big number. A parenthesis means that a parenthesis means that minus infinity is not included and plus infinity is not included. Let's see now the range, how to find the range of a function. The range is the set of all y values. So now we want to look at the y-axis over here, and we start from below here, and you go upward in this direction. Let's start from below. The lowest point this function can have on the y-axis is this one. You can see it starts from here on the y-axis, and this is the value where the range starts. Let's count 1 unit, 2 unit. So it starts from 2 and goes up. Let's go up in this direction, and the values of y goes to infinity because the function is going to infinity. For infinity, we said we use a parenthesis to indicate that this upper bound over here is not included. However, 2 is included in the function. This function passes through this point. So 2 is included. To indicate this, you use a square bracket. So there's a difference between using a parenthesis and square bracket. A square bracket means that this point is included in the range or in the domain. If you use parentheses, this means that this number is excluded from the domain and from the range. Another example, determine the domain and range for this function. As you can see, this function goes like this. And we mentioned in the previous slide, whenever you have an open circle like that, not a full circle, this means that this point is excluded. For this one, this is a full circle. This means that this point is included in the function. Let's go ahead and find the domain. Again, domain are the x values, so we're gonna look at the x axis. It goes from left to right. We start from the left. As you can see, this function comes from far, far away. These arrows mean that this function goes from far, far away from the left, which means that this is minus infinity. And for minus infinity, we always use parentheses. And this function goes into this point. This point is included. So as you can see, the x-axis, are all the values on the x-axis are included in the function. And this function goes to infinity. So all the values here, x values, are included to until infinity. So we again write the domain minus infinity and infinity. We close the parentheses, which shows that infinity is excluded. Minus infinity and plus infinity, for these two, you always use parentheses. for the range. Again, the range is the set for all y values. So we're gonna look at the y-axis. We start from below and we go upward in this direction. So let's start from below. The lowest point this function can take is this one. As you can see, below this point, there's no, the function doesn't extend beyond this point. So there's no y values over here, as you can see, no y values. So the lowest point this function can take is this point. So let's find this point. Let's count them. We have 1 unit, 2 unit, 3, 4, 5, 6, 7, 8, 9, 10. This is minus 10 because this one is in the negative direction below the origin. So which means that this is minus 10. Minus 10 is included, so we will use a square bracket. This one is included and the function passes through this point where y is equal to minus 10. And let's go upward now, one step at a time. All these are included. We have y values. Has all these points have y values. So all these are included going upward in this direction, and the function goes up, and all these points have y values until infinity. So we're gonna write minus 10 infinity. Another function. Let's start with the domain from left to right. Let's examine the x-axis. This function goes back to infinity, to minus infinity. If we extend it, because we have an arrow, it goes all the way back. So all these points, we have x values for all this graph. So we're gonna write, it starts from minus infinity and the function goes to the right until this point. This point is not included. If you project over here, this point is not included. However, we have a full circle, which means that this point is included in the function. Again, let's see the x value of this function. This is goes like this. This is included in the function. All these points are included in the function. We still going to the right until this point. So the function stops at this point. It doesn't extend to infinity as the previous cases. Like this one, you have an arrow. The function or the graph stopped at this point. So let's find this point. This point is 1 unit, 2 unit, 3 units, and 4 units. So the x values take the x values take or starts from minus infinity and goes and ends until 4. 4 is included because this is a full circle, which means that this point is included in the function. As for the range, examine let's examine together the y-axis. It starts from below and we go upward one step at a time. The lowest point this function can take, as you can see from here, the lowest point is this one. And the value, let's delete these lines, all these lines, so we can see. Okay, much better. So this range, the range, as you can see, there's nothing here, nothing here. So there's no y values. The first one, the first point or the first y value starts from here. And this is 1 unit. So we're gonna write 1, then there's a discontinuity here. There's no y values over here. So we're gonna write just 1 union Union means that we have a discontinuity between this point and this point, and the function continuous continues from this point up to this point. So again, union, this is 2, and this is 8. So then it continues from 2 to 8. This is a full circle and this is a full circle. So both points are included in the function. So we're going to use a square brackets for 2 and 8 to indicate that 2 is included and 8 is included. Let's find the domain of a function now algebraically. In the previous slides, we determined the domain and the range of a function graphically. Now we're going to do some calculations to find the domain of a function. The things you have to look in the function in y equal to f of x, two main things. Whether you have a fraction, you don't want to divide by 0 because you cannot divide by 0. This is undefined. And you cannot take the square root of a negative number. So let's take an example and see how to find the domain of a function. Given that f of x is equal to x plus 7 divided by 2x minus 1, we said that we cannot divide by 0. So this one should not be equal to 0. So we to find the value of x that gives you the denominator to be equal to 0, let's write 2x minus 1 equal to 0 to find this value. 2x minus 1, solve for x, you're gonna find that x equal to half, which means that if you replace x here, the denominator will be 0, and this is a problem and you don't wanna to do that. Let's try it out. 2 times half, let's replace the value of x equal to half to check whether this will give you a 0. So 2 times half, which means 2 divided by 2 is equal to 1. So this one will give you 1. 1 minus 1 is equal to 0. So you cannot divide by 0 in mathematics. You will get x plus 7 divided by 0. So we can say here, for this function, x cannot be equal to half. So in this case, we write the domain as follows. The domain starts from minus infinity and goes all the way to the right until you end up at half. But half should be excluded, since if you replace x equal to half, you will divide by 0 and you cannot do that. So we will exclude this point in the domain and you're gonna write it in the domain. So minus half, minus infinity to half, and both are parentheses to indicate that minus infinity is excluded from the domain and half is excluded from the domain. So when you tend towards half, there will be a discontinuity here because this function cannot take a value of x equal to half. So we're gonna use union for discontinuity, and then again the function will continue after half to infinity. So all these points are included, all these points are included except for half. Half is excluded up to infinity. Another example, x minus 4 divided by x squared plus 9. So x squared plus 9 cannot be 0 because we cannot divide by 0. To find which value of uh, which value uh, for x that would give you the denominator to be 0, we're gonna write, let's go here, plus 9 equal to 0 to find the value of x. So x squared is equal to minus 9, which means that x is equal to radical minus 9. You cannot solve radical of a negative number, which means that there's no solution for this one. There's no value you can replace in x that will give you a negative number in the denominator. So we don't have a problem over here. So we're gonna write minus infinity to plus infinity, which means that you can take any value of x, any value, you replace it here, and you're not gonna divide by 0, which is a good thing. Okay, so write the domain of each function in interval notation. This is a skill practice, and the results can be found in the ebook. For this one, k of t, this function is equal to radical t plus 4. To solve and this one, we were gonna write this inequality. T plus 4 is greater or equal to 0. Why do we write this one? Because this one cannot be negative. We mentioned before that you cannot take the square root of a negative number. They should be always positive. So we write this term over here should always be positive. Let's solve it. Solve for t. We take 4 to the right side, t, and you will get t is greater or equal to minus 4. Let's graph it. What does it mean t greater or equal to minus 4? This means that values of t will start at minus 4 over here, and all the values of t it's gonna take are greater than minus 4. Greater than minus 4 means that it's going in this direction. So all these values are included in the domain. So we're gonna write a square bracket minus 4. This is included because we have an equal here. You can see t can be equal to minus 4 up to infinity. Infinity is excluded, and you can see it over here. For this function, we don't have any problem. There's no square root. There's no denominator to check if you're gonna get a 0. So all these numbers from minus infinity, from here to here, from minus infinity to plus infinity, are included. So we're gonna write all t values can be between minus infinity and plus infinity, except for minus infinity and plus infinity, which are excluded. The last part in this lecture, we're going to interpret a function graphically. We have this function y equal to f of x, and we need to find f of minus 3. So this is the function. What does that mean? This means that x is equal to minus 3. We're gonna locate where is x equal to minus 3. Minus means in the negative direction, and 3 means 3 units. This is minus 1, this is minus 2, and this is minus 3. We extend this one. We take a ruler and you draw a straight line, and where it meets the function, you find the value of y. This is again minus 3. Let's count. Minus 1, minus 2, and minus 3. This means that for x, this means that for, for x equal to minus 3, y will be minus 3. Recall that f means that f is y. F is y. So whenever you're evaluating the value of f, this means you're evaluating the value of y. So for x equal to minus 3, y is equal to minus 3. Let's solve this one. In this case, x is equal to 0. Where is x equal to 0? Here. This is x equal to 0 units. We don't move to the right or to the left. You're at 0. Where does this function be at x equal to 0? What is y? Let's count. This is y, where x is equal to 0. Y here is 2, because we have 2 units. So in this case, f of 0 is equal to 2. Another example, let's take f of x equal to minus 1. Now, you have the value of y, because f is y, okay? F is equal to minus 1. We need to find the value of x. So if y equal to minus 1, this is y. This is the y-axis. Let's count 1 unit in the negative direction, which means this is minus 1. Let's find the value of x. We go like this, where it meets the function. We go to x, and x is 1. For y equal to minus 1, x is equal to minus 1. Let's find y equal to 1. This is y equal to 1. For y equal to 1, let's extend it like this, okay? In both directions, to the left and to the right. We're gonna see that for y equal to 1, this will meet the function here. We go back to x to see the value of x. This is 1, this is 2 units, so the value of x is 2. You're gonna ask, what about this point? This point is excluded because this is an open circle, and open circle are excluded from the function, so we don't have a point over here. Determine the x-intercept. X-intercept is the point where the function intersects with the x-axis. If you look at this function, this curve doesn't intersect with the x-axis at all. You don't see an intersection between this curve and the x-axis, so we don't have x-intercept. However, for y-intercept, yes, we see that at this point the curve cuts the y-axis over here. Let's find this point. Let's determine x. X is 0. Go downward to see the value of x, and this is the origin, and which means that the value of x at this point is 0. As for y, we count 1 and 2. This is 2. So the y-intercept point is 0, 2. Determine the domain of f. The domain. This function has an arrow, which means it extends to minus infinity and then goes to infinity. So we're gonna write the domain is minus infinity and infinity, and takes all the values for the domain. Domain, we mentioned that for the domain, we look at the x-axis, and this function takes all x values in the domain. This is minus infinity plus infinity. As for the range, we look at the y-axis. Let's examine this. We start from below, from here, and we go in upward direction. So since the function extends to minus infinity, we have all y values up to this point, and the function stops at this point, and we have discontinuity. So we're gonna write for the range, we start from minus infinity takes all the values of y and stops at -1. We use a square bracket because -1 is included, and you can see here we have a full circle. Then we have a discontinuity here. There's no y values. There's no function over here. No y values. So we're gonna use union. Then the function starts again from here. But this one is excluded. This point is excluded. So there's the publisher who prepared this, made this a square. Yes, because he included this point. Why? Because y can take equal to 1, because you can see it over here. This point is included. So we're gonna write 1 to plus infinity. The function goes to infinity like this, take all the values, and ends at infinity. So again, we use a parentheses to indicate that this is that infinity is excluded. A square bracket means that 1 is included in the function. This is a skill practice for you again, and thank you for watching, and see you in the next lecture.